Well, glad you're back on, and let me just take the time to welcome everyone again to our Safer Sim webinar. My name is Jacob Hayden, and I'm the program coordinator for Safer Sim at the University of Iowa. Safer Sim, or Safety Research Using Simulation, is a Tier 1 university transportation center with the research priority of promoting safety. And our webinar series features research happening within our center. So thanks for joining us today. Before we get started, I do want to point out our chat box in your Adobe Connect window at the lower right side. Please use this chat box for any questions or comments, and we will address those comments at the end of the presentation. So now I'm pleased to welcome our presenter from the University of Massachusetts-Amherst, Alyssa Ryan.
Great, thank you, Jacob. So today I'll be presenting the research work of the UMass team, Dr. Cole Fitzpatrick, Dr. Michael Nodler, Dr. Eleni Christofa, and myself, Alyssa Ryan. So to start off, I'm going to be going over a quick agenda of what I'll be presenting today. I'm beginning with the introduction and motivation of this work, the objectives and the scope, and then moving into the background and the methodology, and then finally concluding with the results and policy conclusions and recommendations. So to begin, I'm going to talk about why this is important to study. So we understand that addressing human behaviors can decrease or, on the other words, increase driver safety risk at the same time. So it's important to understand what we can change in the environment to make the road safer. So we also understand that distraction is a large cause of fatal crashes, reporting 9% in just 2016 in the United States. At the same time, we have drones or unmanned aerial systems that are being increasingly used near surface transportation for traffic monitoring, agriculture monitoring, collecting data, and in other words, hobbyist use in other ways as well. So with those two, we have to understand how drones have the potential to distract drivers if they're flown near the roadway. So this study also happened around the same time I was beginning a different project for MassDOT that focused on collecting speed data for UAS. And this specific study is just one example of how drones can be used to collect efficient and helpful data near roadways. So we don't want to discount flying drones near roadways in all cases, as they can collect detailed data through vehicle tracking to help set speed limits, to assist in road safety audits or corridor studies, just to name a few. So the specific scope of this research and the objective was to study driver performance in response to drone presence in the vicinity of surface transportation under different scenarios. And those specific scenarios are based off of what we've understood in literature so far. So the initial objective before we developed this study was to understand how drones are currently being used near surface transportation and how they will intended to be used in the future. So we really have to understand the potential concerns that we may have with drones being flown near surface transportation. And so from here, we understood that we needed to understand how drones impact driver performance in terms of their visual attention, their speed, and their lateral position due to a number of variables. So the scope of this research specifically focused on drone height. So does the height impact driver performance? Drone location on a roadway, and whether the operators are present or not with that drone flight. Examples of drone variables that we didn't study could be the size of the drone, so how large a drone is, or the color, as well as the lateral position from the roadway and motion type, among others. There are several different ways in which you can fly a drone, and we really only focused on a specific scenario. So now I'm going to go into the background of why distraction is important to understand from a general perspective, an external distraction perspective, as well as drone regulations that exist in the US and globally today. So distracted driving is essentially any activity that diverts attention away from driving, and these can be broken into three different types. So we have visual distraction that takes your eyes off of the main roadway, manual distraction that takes your hands or other physical features away from the driving task, and then you have the cognitive distraction that takes your thoughts away from the driving task. So in literature today, we really do understand internal distractions are a significant problem. Cell phone use, for example, talking to friends in the car, for example, are well understood in literature. However, external distractions have been less concentrated in recent years. And that's really what this research takes on. So external distractions typically take the form of a visual distraction. And in the late 1990s, it was shown that external distractions were identified as contributing factors to about 30% of all crashes. And it's with more external distractions potentially existing today, this number may have been risen, though there aren't any current studies that look at external distractions in the way this study did. Another issue with external distractions is that visual glances greater than 2 seconds continuously can double the risk of a crash or a near crash. So visual distractions can become very serious if they last for a significant amount of time, and they aren't just quick glances. And then external distractions have been found to not only affect new drivers, but also more experienced drivers. So this isn't just a new driver issue, but rather external distractions can really impact drivers of all driving experience. So specifically looking at, we have one study that we found in our literature review that looked at the external distractions due to drones specifically, and this was a study by Hurwitz et al. In 2019 using a driving simulator. And they studied the lateral distraction due to lateral offset of the drone, the flight path, and the land use. And they found that the frequency and length of glances to the drone increased as the lateral distance from the roadway increased. So the further the drone was away from the roadway, the less distracting it was, or less glances occurred at it. And then the same distraction occurred regardless of the flight path. So it didn't matter if this drone was moving in a scanning pattern, a racing pattern, or simply taking off. And then finally, they found that the drone was most distracting in a rural environment. And this study definitely influenced how we decided to shape our study because we really wanted the most potentially distracting environment for the study to take place. So to jump into regulations that currently exist with drone use in the United States, there are a number of regulations that drones must be under a certain weight. They must be within visual line of sight of the pilot or their team member, their visual observer. They can't be flown over a certain altitude, and you must have a license to operate a pilot. You must have a commercial license to operate a drone, and that's this picture here. You only have to pay around, I believe it's now $150, and it must be updated every 2 years, and it's a test you take. However, the biggest regulation that exists related to flying drones near the roadway is this one, that operations cannot be flown over human beings or over moving vehicles. However, in the US, there's no regulation on flying a drone in the proximity of a roadway. This exists in other countries, so here are a couple countries listed here with their regulations. They have, a lot of countries have, you can fly at least 100 meters away, 100 feet away from vehicles or moving vehicles. However, in the US, we don't have any current regulations that specify these, so you can fly right next to a roadway, for example, as long as you're not flying over a moving vehicle. So this study took place in the Human Performance Laboratory on the UMass Amherst campus using a 2013 Ford Fusion simulator with 330 degrees of view and an eye tracker device. And the software we used to develop the simulation was Real-Time Technologies Incorporated. And then we followed up with a Qualtrics survey to collect demographic information as well as their experience in the simulator as well as their perspective on drones. And I'll go into the details of that. So our base scenario was a simple curve design. So you'd go straight, you take a right curve and you'd go straight from there. And this was to make sure that the drivers couldn't see the drone from the beginning of the scenario when they first started. Took place in a rural area, a couple pre-programmed vehicles traveling on the opposing lane to make it seem more realistic. And we developed the pilots. You can see here one flying the drone, one being the visual observer in Google SketchUp, and transferred them into the simulator software. And the drone we used, you can see it in the left picture, is a quadcopter, and our colleagues, our friends over at Oregon State University, allowed us to use the same drone they used in their study for consistency in the study there. Okay, so study design, upstream and downstream location, which I had mentioned, to minimize biases in the study. So we had 3 dependent variables: speed of driver, lateral position, and eye glance behavior. And we also included a static evaluation. And this was really to understand participant view and familiarity of UAS, to then understand the impact this may have on driver performance around a drone. And this was developed in Quadtrix. We asked questions of demographic information and other specific questions regarding to the study. Here's a brief screenshot of our participant demographics. We had a younger skew toward the age, and a even gender distribution, and a fairly even driving experience distribution. And I'll explain why we had a younger age range in a future slide. So in terms of the speed results, we calculated the reduction in speed from 100 meters prior to the drone and pilot to the drone and pilot to really understand if drivers were decreasing their speed in their approach to the drone location. And we ran some Wilcoxon pairwise t-tests based on the median because the data was not normally distributed. And we found that gender was not a significant factor. However, age and driving experience was. So the younger drivers tended to go faster and had a lower, their speed reduction wasn't as high as older drivers, more experienced drivers were. And this significance likely exists due to the fact that prior studies have shown that younger drivers are less likely to make sound critical decisions compared to more experienced drivers, such as traveling too fast for conditions. We also analyzed the results of the speed in conjunction with some questions we had asked in the Qualtrics survey study part of this. So, have you seen a drone in flight in your roadway? You could either respond yes or no. And should drones be allowed to be flown in your roadways? And the first question we found was statistically significant in their speed. So those who had seen a drone before in the real world, in flight near a roadway, were statistically more likely to slow down in their approach to the drone compared to those who had not. We found no significance in speed due to drone height or pilot presence, and there was only one significant relationship between the speed, the change in speed, and the percent of time observing the drone. So if drivers spent more time observing the drone, they had a lower change in speed than those, they had a negative change in speed compared to those who had less time observing the drone. And this lack of correlation, there's only this one correlation, is likely due to the fact that visual distraction is not usually enough to change average speed. So there has to be more distraction involved for that to happen. In terms of the lateral position, there were no significant results found in any of the right and left scenarios. And this is likely due to the fact that potentially maybe it's the lack of drone movement or the pre-programmed vehicles in the opposing lane. So there could be more studies done on lateral position and drone flights to really understand this better. In terms of visual attention, there was a statistical significance in the median average glance lengths between glancing at the drone and pilots in the drone and pilot scenario, and then also glancing at the drones in the drone only scenarios. The drone-only scenarios were those scenarios that did not have operators present in them. So as you can see here, the average glance length was a bit higher for the pilot and drone scenarios, likely due to the fact that there is more to look at. However, the numbers are still quite close, given there's only a drone to look at in the drone scenario. Another significant finding was that there were only, in 9 of the 156 analyzed videos, drivers looked back in their rearview mirror at the drone and pilots after passing them. And then in 17 of them, participants looked at the drone or pilot for 2 seconds continuously. Again, that is a critical glance in terms of this can result in a double risk of a crash occurring. So briefly to go over the results of the static evaluation, 8 of the 28 participants did note that the pilots or drones could be a distraction without even being asked about distraction, and several others noted that drones or pilots made them look away from the roadway. And then of those who had seen a drone before in the real world, which was almost everyone except 1, 19 had not seen them near a roadway. However, 8 had seen a drone in flight near a roadway. So this insinuates that this is happening already. Of those who had seen a drone in flight, we had 4 had seen one while driving a vehicle, another 4 while riding as a passenger in a vehicle, so on and so forth. And of those who had seen a drone in flight while being a driver in the vehicle, wondered what it was doing there. All of them wondered what it was doing there and why it was there. 1 was even nervous that it might hit their vehicle. So none ignoring the situation, it is reasonable to think about that since they recalled these situations, there's a potential for a cognitive distraction happening, not just a visual distraction, in the presence of a drone while driving. And then finally, the final question was, should drones be allowed to be flown near roadways? And there wasn't an even consensus on this one. So conclusions from the static evaluation, we recognize that drones could be distracting. Drivers are aware of this, and drivers may think that the drone is above them even when it is just adjacent to the roadway. Some noted that in the Qualtrics survey. Some participants had also seen a drone in flight near a roadway, indicating they are being currently flown near roadways in the US. And since participants spent time thinking about the drone while driving and they remember these situations, there is a potential for a cognitive distraction. And generally, there was agreement that if the pilots of the drones were responsible and experienced pilots, that they would feel safe driving around them. And finally, we have driving performance conclusions. So we found that drivers did slow down in their approach to the drones on the roadside if they had previously seen a drone in flight near a roadway before in the real world. So if someone is more familiar with drones, they are more likely to slow down in their approach, or that's what our results suggest. Otherwise, drivers don't really change their speed while passing a drone on the roadside. So again, I mentioned that drivers may be cognitively and visually distracted by drones, and another reason for this would be that they looked in their rearview mirror after passing them. And drones and pilots were sometimes critically distracting in these continuous 2 seconds or more glances, so this could be an issue that, a safety issue, certainly. And then finally, drones were just as visually distracting at any drone height, though we only went up to 60 feet above ground level, so if a drone was flying at a higher height, this could minimize this level of distraction. So the recommendations of this work are simply that only licensed pilots should be allowed to be flown in the vicinity of roadways, if they should be allowed to be flown at all, and these could come in the form of strict regulations, enforcement on pilot licensing. And then also, given the amount of visual distraction, it is recommended that policy be created to simply limit the situations in which drones are allowed to be flown in the vicinity of roadways. These could come through in regulations limiting the use of drones, for example. There are a couple limitations of this study. The within subjects design could cause fatigue effects, though they only participated in 1-minute scenarios, so those were minimized. The heights of the drone age scenarios were limited to only 3 different heights, and the overall age of the participants was younger in terms of licensed drivers in the US. Future work could study the altitude at which drones are generally unnoticeable to drivers, where it could be safe to fly. And then finally, the analysis of cognitive distraction, understanding how that could specifically impact drivers. So there is one more study that recently came out in 2020 by Barlow et al. That studied the use of temporary traffic control devices prior to drones. And I wanted to add this in here for all of those situations where drones do need to be flown your roadways for work purposes. And they found that the current survey crew signed in the MUTCD cannot effectively communicate to drivers the disruption of drone flight safely, and they have developed sign alternatives that have been proven to reduce driver speed better than the current sign that exists today. So if you're interested, I recommend checking that out. And this kind of aligns with our study at hand that said that drivers feel more safe around experienced pilots and those they trust. So that kind of aligns with this work as well. So with that, thank you very much. You can find the final report on the Safer Sim website of this work, and I apologize for the in and out of my internet connection today. Thank you.
Thanks, Alyssa, for managing that technical difficulties. I think it turned out really well. And I would like to mention, so I just included the link to that final report on our website. If anyone does want more detail on this study, feel free to check that out. We do have time for questions or comments, so I will open that up to the group. And then one quick plug for our next presentation, which will be Tuesday, August 4th at the usual time of 3 p.m. Eastern, 2 o'clock Central. And this presentation will showcase one of the first projects of the cooperative research program between our center, Safer Sim, and the AAA Foundation for Traffic Safety. So we are looking forward to that, and we'll be sending the information out for that shortly. Oh, and we do have a question come in here from Ryan. So Alyssa, if you plan on researching a safe minimum altitude to avoid distraction, will you also be seeking a minimum lateral distance from the road that the drone would need to achieve altitude in order to be unnoticed?
Yes, so it's a very important question, and what I had mentioned was there is definitely a relationship between the altitude and the lateral position together and how they combine to be a distraction. Because the closer you are to the roadway laterally, of course, you probably need to go at a higher altitude for it to be less distracting. So I would hope that one day we'll come up with some sort of a relationship that explains where is the safest lateral position combined with the altitude.
Okay, well, we are at time. Thanks again, Alyssa, and thank you everyone for joining. Again, I will encourage you to reach out to Alyssa and their team at UMass if you have any follow-up questions directly with this project. So thanks for joining. Enjoy your day, and we will see you at our next presentation.
Thank you.